Okay, in this video, we're going to solve this three systems of equation using Gaussian elimination with echelon form. And in a later video, we'll solve it using row-reduced echelon form. So with echelon form, you'll have a number here, number here, number here, and the bottom left would be a 0. This is for two systems of equations, but now we have three, so it's very similar. All of these will be numbers, but the bottom left corner, this piece, this piece, this piece would be 0. And so let's get started by rewriting this problem. So we have 1x, so I'll put 1. 2y, so 2. Negative 1z, so negative 1. Then we have 2x, 3y, and negative 2. Last one is 3x, negative 4, and 1z. Dash, 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 we put 0, negative 1, 6. So we're going to use matrix operators. And so if we want to eliminate 2, we could do that if we take row 2, this row right here, we subtract 2 times row 1. Minus 2 times row 1. And so now we have to apply it. So the first row would remain the same. 1, 2, negative 1, dash, dash, dash. We have a 0. The second row changes. So row 2 minus 2 times row 1. So 2 minus 2 is 0. 3 minus 2 times 2 is 4. 3 minus 4 is negative 1. Negative 2 minus 2 times negative 1. So negative times a negative is a positive. And so we get negative 2 plus 2, which is 0. Now we have this piece, so negative 1 minus 2 times 0, so just negative 1. And the last piece remains the same. So 3, negative 4, 1, and 6. So we got this piece to be 0. Now this piece and this piece also needs to be 0. We could take row 3, this 3 right here, and subtract 3 times row 1. So minus 3, row 1. And so we're going to have, again, the first row would remain the same, 1, 2, negative 1, dash, 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 0. Second row would remain the same, 0, negative 1, 0, negative 1. But the third row changes. So we have row 3, so 3 minus 3 times 1, so negative 3. 3 minus 3 is 0. Then we have negative 4 minus 3 times 2. Negative 3 times 2 is negative 6. Negative 4 minus 6 is negative 10. Now we have 1 minus 3 times negative 1, which is going to be positive 3. 1 plus 3 is 4. And then the last one, we have 6 minus 3 times 0, which is 0. So we have 6. So we're almost there. This is 0, this is 0. Now this needs to be 0. So we can still focus on row 3. So we're going to take row 3, which is a negative 10. So we need to get rid of negative 10, so we need to add 10. We could do that if you subtract 10 times row 2, because row 2 we have a negative 1, so negative 10 times negative 1 would give us positive 10, and so now we need to apply it. So again, first row would remain the same, 1, 2, negative 1, dash, dash, 0, and then the other one is 0, negative 1, 0, negative 1, and now we're doing the third row. So we have 0 minus 10 times 0, which is just 0, negative 10 minus 10 times negative 1, which gives us positive 10, so negative 10 plus 10 is 0. Now we have 4 minus 10 times 0, so that's going to give us 4. And then the last one, 6 minus 10 times negative 1, so that's going to give us a positive 10. 6 plus 10 is 16, and we can close it. So now what we have is we have 1x plus 2y minus z is equal to 0. We'll write that down. X plus 2y minus z is equal to 0. The other one is we have 0x, 0z, we have negative 1y. So negative y is equal to negative 1. The last one, 0x, 0y, 4z. So we have 4z is equal to 16. At this point, we can solve this problem. We could divide both pieces by 4. Divide by 4, divide by 4. Z is equal to 4. We can close this. Now, if you want to get rid of negative in front of the y, just divide by negative 1, divide by negative 1. Y is equal to 1. And then the last one, just plug it in. So we have x plus 2 times 1 is 2 minus z, so minus 4, is equal to 0. We can clean it up. 2 minus 4 is negative 2. So x minus 2 is equal to 0. We can add 2 here, add 2 there. X is equal to 2. So now we know x is 2, y is 1, z is 4. And if you want, you can always check. So we said x is 2. We said y is 1, and we said z is 4. I guess we can jot it down here. We said x is equal to 2, y is equal to 1, and z is equal to 4. So 2 plus 2 times 1 is 2. So 2 plus 2 is 4. 4 minus 4 is 0. That works. Try the other one. 2 times 2 is 4. 3 times 1 is 3. 4 plus 3 is 7. And then we have negative 2 times 4 is negative 8. 7 minus 8 is negative 1. That's correct. Last one. 3 times 2 is 6. Negative 4 times 1 is negative 4. 6 minus 4 is 2. 2 plus 4 is 6. That's correct. And that's pretty much it for this problem.